Hello there, my curious friend. Thank you for joining me tonight on this strange journey through the cosmos. Tonight, we're going to explore some of the most terrifying worlds that astronomers have ever discovered. Planets so hostile, so alien, so utterly nightmarish that they make our worst science fiction seem quaint. These are real places, floating out there in the darkness, waiting to remind us just how precious and fragile our little blue marble truly is. But before we venture into these cosmic horrors, I'd love to know, where are you listening from right now? And what time is it where you are? I always wonder about the quiet moments when we choose to explore the universe together. If you find yourself drawn to these gentle explorations of science and space, please consider giving this video a like or subscribing. Your support helps me continue creating these peaceful journeys through the cosmos for fellow stargazers like yourself. Here's my confession. I've been fascinated by scary planets ever since I was young, but I promise you, no matter how terrifying these worlds become, I'll keep my voice calm and soothing. Think of me as your cosmic tour guide through the universe's haunted house. So settle in, let your breathing slow, and allow yourself to drift along as we visit 30 of the most frightening planets ever discovered. Close your eyes if you wish. Let the darkness of space embrace you as we begin our journey into the cosmic unknown. This planet's blue color doesn't come from vast oceans or a life-giving atmosphere. Instead, it comes from tiny particles of silicate suspended in the air, essentially microscopic glass shards floating in the atmosphere like glitter in a snow globe. But unlike the gentle dance of snowflakes, these glass particles are caught in winds that race around the planet at speeds reaching 5,400 miles per hour. That's nearly 7 times the speed of sound. Our first stop takes us 63 light-years away to a world that looks deceptively beautiful from space. Hard HD 1897733b. Hard appears as a stunning cobalt blue marble, reminiscent of our own Earth when seen from orbit. But this resemblance is perhaps the cruelest trick the universe has ever played. Imagine standing on the surface of this world. If such a thing were possible, the glass doesn't fall gently downward, like rain on Earth. Instead, it flies horizontally, driven by these supersonic winds that never cease. The very air would become a sandblaster of cosmic proportions. Each breath an impossibility, as your lungs would be shredded by glass particles moving faster than bullets. The planet orbits its star so closely that it completes 1 full year in just 2.2 Earth days. This proximity creates a tidally locked world where one side perpetually faces the star while the other remains in eternal darkness. The temperature difference between these sides drives the relentless winds that carry the glass rain in an endless howling circuit around the planet. But here's what makes this world particularly haunting. The glass rain isn't just any glass. It's created from the planet's own atmosphere being constantly recycled through extreme temperatures. On the day side, silicate compounds are heated to over 1,800 degrees Fahrenheit, turning them into vapor. As these vapors are swept to the night side by the screaming winds, they cool and condense into those tiny glass droplets that then get caught in the atmospheric circulation. Scientists discovered this terrifying weather pattern using the Hubble Space Telescope, which detected the unmistakable spectral signature of silicate particles in the planet's atmosphere. The fact that we can peer across 63 light-years of space and determine that it's raining glass on another world still fills me with a mixture of wonder and existential dread. What's particularly unsettling is how this discovery changed our understanding of planetary atmospheres. Before HD 1897733b, we thought we understood weather. We knew about rain, snow, hail, all the familiar forms of precipitation that make Earth's weather systems seem predictable and gentle by comparison. But this world taught us that the universe has a far more violent imagination than we ever suspected. As we observe this world through our telescopes, we're essentially watching a planet-sized demonstration of chaos theory in action. Every particle of glass rain is following the laws of physics, yet the overall system is so complex, so violent, that it becomes a kind of cosmic madness. The planet has been locked in this state for millions of years, possibly billions, turning in its eternal dance of destruction. The planet itself is what astronomers call a hot Jupiter, a gas giant that orbits incredibly close to its star. Hot, but unlike our own Jupiter, which sits safely in the outer solar system, this world is caught in a perpetual state of atmospheric violence. The star's radiation constantly strips away parts of the atmosphere, while the extreme temperature differences create weather patterns that would make the most severe Earth storms look like gentle summer breezes. There's something deeply unsettling about the idea that somewhere out there, on a world that looks so much like Earth from a distance, glass rain has been falling sideways for longer than complex life has existed on our planet. It's a reminder that the universe is filled with worlds that would kill us in seconds, worlds where the very concept of safety is meaningless. Yet there's also something beautiful in this terror. The cobalt blue of HD 189733b is genuinely stunning, a testament to the fact that even the most hostile environments can create their own form of cosmic art. The glass rain itself, viewed from the right perspective, might be the most spectacular light show in the galaxy, billions of tiny mirrors catching and reflecting starlight as they race through the atmosphere at impossible speeds. As we drift away from this world of glass rain, let yourself imagine the sound it might make, not the gentle patter of earth rain, but perhaps a constant howling shriek of wind and the endless tinkling of glass particles colliding in the darkness. It's a sound that has been playing for eons, a planetary symphony of destruction that no ear will ever hear. But the universe, as we're learning, delights in dashing such hopes in the most spectacular ways possible. Kepler 438b orbits a red dwarf star, one of those small, seemingly gentle stars that burn for trillions of years. These stars appeared to be perfect for life because they're so long-lived and stable. But we've learned that red dwarf stars harbor a terrible secret. They're prone to massive stellar flares, explosions of radiation, and charged particles that make our sun's worst tantrums look like gentle hiccups. 640 light-years from Earth, there exists a world that once gave astronomers hope, and then slowly filled them with dread. Kepler 438b sits in what we call the habitable zone of its star, that precious distance where liquid water might exist on a planet's surface. For a brief shining moment when it was discovered, this world seemed like it might be Earth's cousin, a place where life could potentially take hold. The star that Kepler 438b orbits unleashes these flares with terrifying regularity. Every few days, the star essentially explodes, sending waves of deadly radiation across the planet's surface. These aren't gentle solar winds like we experience on Earth. These are radiation storms so intense that they would strip away the planet's atmosphere molecule by molecule, layer by layer, until nothing remains but bare rock under a sterilizing bombardment of cosmic fury. The radiation levels during these flares are estimated to be hundreds of times stronger than what Earth experiences during our sun's most violent outbursts. And while Earth has a strong magnetic field and thick atmosphere to protect us, Kepler 438b likely lost its magnetic field long ago, if it ever had one. The constant bombardment would have stripped it away, leaving the planet defenseless against its star's regular fits of violence. Imagine being on the surface of this world during one of these flares. The sky would light up with an otherworldly aurora as the radiation slammed into what remained of the atmosphere. But this wouldn't be the gentle, dancing lights we see in Earth's polar regions. This would be a sky on fire, a celestial scream of electromagnetic energy that would cook any living thing in seconds. Scientists have calculated that each flare delivers enough energy to strip away the equivalent of Earth's entire atmosphere, and these flares happen every few days. The cumulative effect over geological time would be to create a world that's been pressure-washed by radiation for eons, scrubbed clean of any possibility of life as we know it. What makes this particularly haunting is the timescale involved. This isn't a one-time catastrophe or a brief period of instability. This bombardment has been going on for billions of years and will continue for billions more. The star is essentially sterilizing its own planetary system on a regular schedule, ensuring that nothing complex can ever evolve or survive. But here's what makes this world particularly terrifying. From a cosmic perspective, it's not alone. Red dwarf stars, make up about 75% of all stars in our galaxy. If they're all prone to these violent outbursts, then the majority of potentially habitable worlds might be caught in similar radiation nightmares. The universe might be filled with worlds that look perfect for life, but are actually caught in permanent cycles of sterilization. The radiation from these flares isn't just deadly to life, it's deadly to the very possibility of life. The high-energy particles break apart complex molecules, the building blocks that life needs to get started. Even if somehow life managed to begin during a quiet period, the next flare would reset the clock, breaking everything down to simple atoms again. What's particularly cruel is that Kepler 438b humblely started with everything it needed for life. It's roughly Earth-sized, sits in the habitable zone, and likely had water and a substantial atmosphere when it was young. It might have even had a magnetic field. But over billions of years, the radiation slowly stripped all of this away, leaving behind a naked, irradiated rock. The planet's surface today is probably like standing on a cosmic beach, where the waves are made of deadly radiation instead of water. Every few days, another wave crashes over the world, carrying away a little more of what makes it habitable. It's a slow-motion apocalypse that has been playing out for longer than our solar system has existed. Yet there's something almost poetic about this world's struggle. Despite the constant bombardment, Kepler 438b continues its orbit, holding its position in the habitable zone like a sentinel, refusing to abandon its post. It's a world that could have been Earth's sister, now serving as a monument to the universe's capacity for prolonged violence. The silence around Kepler 438b is profound, not the comfortable quiet of space, but the terrible silence of a world where nothing can speak, nothing can grow, nothing can dream of tomorrow. As we drift past this radiation-soaked world, consider how it challenges our assumptions about habitability. We look for planets in the Goldilocks zone, not too hot and not too cold, but we're learning that location isn't everything. Sometimes the most Earth-like worlds are the most deceptive, offering the promise of life while delivering only endless sterilization. 870 light-years away, we encounter a world caught in perhaps the most dramatic death spiral in the known universe. WASP-12b is being eaten alive by its own star, stretched and distorted like taffy in a cosmic candy machine, slowly dissolving into space in a process so gradual, yet so inevitable that it reads like an astronomical Greek tragedy. The gravitational forces at play here are almost incomprehensible. The star's gravity is so strong that it has pulled WASP-12b into an egg shape, with the planet's day side bulging toward its stellar parent like a teardrop about to fall. But this isn't a stable configuration. The planet is slowly being torn apart, its atmosphere stripped away and fed directly into the star in a process that astronomers call stellar cannibalism. This planet is what we call a hot Jupiter, but that clinical term barely captures the horror of its situation. WASP-12b orbits its star at a distance of only 2.1 million miles, so close that it completes a full orbit in just 26 hours. To put this in perspective, if you were standing on this planet, you could watch the star grow visibly larger in the sky over the course of a human lifetime. The process is remarkably efficient and utterly relentless. WASP-12b is losing mass at a rate of about 10 billion tons per second. That might sound like a lot, but the planet is so massive that at this rate, it would take about 10 million years to be completely consumed. In cosmic terms, that's barely a blink of an eye, a brief moment of destruction that will erase a world that took billions of years to form. But the heat is just the beginning of this world's torment. The star's gravity is literally pulling the planet's atmosphere away, creating a stream of gas that flows from the planet to the star like a cosmic river of death. This stream is visible to our telescopes as a glowing tail of hot gas extending behind the planet as it orbits, making WASP-12b look like a comet that's being consumed by its own parent star. Imagine standing on the surface of this doomed world. If such a thing were possible, the star would fill nearly a quarter of the sky, a blazing wall of nuclear fire that never sets and never moves. The day side of the planet reaches temperatures of over 4,000 degrees Fahrenheit, hot enough to melt copper and turn rock into vapor. The night side, perpetually facing away from the star, remains comparatively cool, but the extreme temperature difference drives winds that race around the planet at thousands of miles per hour. What makes this particularly haunting is that we can see the planet's future written in its present. The star will continue to grow and heat up as it ages, accelerating the process of planetary consumption. Eventually, all that will remain will be a slightly brighter star, enriched with the heavy elements that once made up a world, and perhaps some rocky debris scattered in a tight orbit. The discovery of WASP-12b changed how we think about planetary death. We used to imagine that planets died in dramatic catastrophes, collisions with asteroids, explosions of nearby stars, or the gradual cooling of their parent stars. But WASP-12b showed us that planets can die slowly, intimately, locked in a gravitational embrace with their parent star that becomes increasingly destructive over time. The planet's atmosphere is being stripped away in layers, like an onion being peeled in reverse. The outer atmosphere goes first, followed by deeper and deeper layers until eventually even the solid core will be consumed. It's a process that transforms a world into fuel for its star, a cosmic recycling program that erases the very concept of planetary identity. The gravitational forces that are destroying WASP-12b are the same forces that hold our own solar system together. Gravity, which we think of as a gentle organizing force, becomes a weapon of mass destruction when taken to extremes. The planet is trapped in an orbit it cannot escape, locked in a dance of death that will continue until nothing remains. There's something deeply unsettling about the timescale of this destruction. The planet has been dying for millions of years already, and it will continue dying for millions more. Any hypothetical observers on the planet would live their entire lives, and their children's lives, and their children's children's lives, watching the star grow imperceptibly larger and brighter, knowing that their world is doomed, but never quite seeing the end approach. Scientists have detected water vapor, carbon monoxide, and other familiar molecules in the stream of gas flowing from the planet to the star. These are the building blocks of life, being fed directly into a nuclear furnace. It's as if the planet is being forced to watch its own potential for life being consumed before its eyes. As we drift away from this doomed world, we carry with us the knowledge that somewhere in the universe, a planet is spending its final moments in the most drawn-out cosmic execution ever observed. WASP-12b is teaching us that the universe has patience for destruction, that some endings are not sudden, but slow, intimate, and utterly inevitable. 489 light-years from Earth, there exists a world where the very concept of solid ground becomes meaningless. WASP-7b is a planet where rock behaves like water, where the day side is an ocean of molten stone, and where it literally rains liquid rock from the sky. This is a world that has turned the familiar cycle of water into a nightmare of geological impossibility. The silence around this world is not peaceful. It's the silence of a countdown that has been running for millions of years and still has millions to go. The planet orbits its star once every 20 hours, locked in such a tight embrace that the day side reaches temperatures of over 4,000 degrees Fahrenheit. At these temperatures, rock doesn't just get hot. It melts, vaporizes, and enters the atmosphere as a gas. The entire day side of the planet is covered in what can only be described as a magma ocean, a sea of molten rock that stretches from horizon to horizon under a sky filled with rock vapor. Scariest was one of the first rocky exoplanets ever discovered, and astronomers initially celebrated finding a world that wasn't a gas giant. Finally, we thought, a planet with solid ground, a world we could imagine standing on. But as we learned more about this distant world, celebration turned to fascination, then to a kind of cosmic horror, as we realized we were looking at a planet that had been transformed into a geological hell. But the nightmare doesn't end there. The night side of Scariest-7b tells a different story, one equally terrifying in its own way. Here, permanently facing away from the star, temperatures drop to a merely hellish 2000 degrees Fahrenheit. In this relatively cool environment, the rock vapor that has been swept from the day side begins to condense and fall as rain. But this isn't water rain. It's liquid rock, droplets of molten stone falling from the sky in a perverse inversion of Earth's gentle water cycle. Imagine standing on the Terminator line between day and night on this world, if such a thing were possible. On one side, you'd see a literal ocean of lava stretching to the horizon, glowing with the heat of molten stone. On the other side, you'd witness the most terrifying weather system in the known universe, storms of liquid rock with lightning that crackles through clouds of vaporized granite and basalt. The composition of this rock rain is particularly haunting. HAV spectroscopic analysis suggests it includes familiar Earth minerals, quartz, feldspar, various silicates, but in liquid form, falling from the sky at temperatures that would instantly vaporize any organic matter. These are the same minerals that make up Earth's mountains and beaches, but here they exist in a state of perpetual liquid cycling that turns the familiar into the impossible. The physics of this world challenge our most basic assumptions about planetary behavior. On Earth, we're used to the water cycle, evaporation, condensation, precipitation. It's a gentle, life-giving process that has shaped our planet for billions of years. But on Coret 7b, the same process occurs with rock. Stone evaporates on the day side, travels through the atmosphere, and condenses into rocky rain on the night side. It's the same physics, but with materials that should never behave this way. Scientists believe that Coret 7b might have started as a much larger planet, possibly even a gas giant, but lost its atmosphere to stellar radiation over billions of years. What we see now might be the exposed core of a former giant planet, a world that has been stripped down to its rocky skeleton and then subjected to such extreme heat that even the skeleton has begun to melt. The planet's surface probably doesn't have a fixed geography in any sense we would recognize. The lava ocean on the day side is constantly churning, driven by temperature differences and the planet's rotation. Continents of cooler rock might briefly form and then dissolve back into the molten sea. It's a world where the very concept of a permanent landscape is meaningless. What makes Coret 7b particularly unsettling is how it represents the ultimate failure of planetary evolution. This world likely had billions of years to develop, to cool, to potentially harbor life. Instead, it became trapped in a state of perpetual geological violence, where the normal processes of planetary development have been turned into instruments of destruction. The planet's tidally locked nature means that this rock-rain cycle has been going on for millions of years and will continue for millions more. The day side will always be a lava ocean, the night side will always experience rock rain, and the Terminator line will always be a zone of impossible weather where liquid stone falls from clouds of vaporized mountains. There's something deeply disturbing about the idea that somewhere in the universe it has been raining liquid rock for longer than complex life has existed on Earth. The storms on Coret 7b have been raging since before the first animals appeared in our oceans, and they will likely continue long after our sun has died. As we drift away from this world of impossible weather, we carry with us the knowledge that the universe can take the most familiar processes and twist them into cosmic nightmares. Coret 7b reminds us that the gentle rain falling outside your window tonight is a miracle of chemistry and physics that under different circumstances could become something far more terrifying. This world forces us to confront the limitations of our Earth-based understanding of matter. When we think of ice, we imagine the frozen water in our freezers, the glaciers on our mountains, the delicate crystals that form on our windows during winter. But Gliese 436b taught us that ice can exist in forms so alien, so impossible, that they challenge our very concept of what water can be. 33 light-years from Earth, in the constellation Leo, there exists a world that shouldn't be possible according to everything we thought we knew about matter and physics. Gliese 436b is a planet where water exists as ice, even at temperatures of over 800 degrees Fahrenheit, where the familiar rules of chemistry have been twisted into something that reads like a cosmic joke played by the universe itself. The silence around this world is broken only by the imagined sound of liquid rock falling like rain. A planetary percussion that has been playing the same terrifying rhythm for eons. But this isn't ordinary ice. This is what physicists call hot ice, or ice savant, a crystalline form of water that can only exist under extreme pressure. The mass of the planet itself creates pressures so intense that water molecules are forced into a rigid, ice-like structure, even at temperatures that would normally turn them into steam. The water is simultaneously frozen and burning, locked in a state that defies our everyday experience of matter. Imagine trying to understand this world with our Earth-based intuition. We know that ice melts when heated, that water boils when it gets hot enough. But on Gliese 436b, the water is under such crushing pressure that it remains solid even as it reaches temperatures that would cook any living thing in seconds. It's ice that burns, water that remains frozen while glowing with heat. The planet is what astronomers call a warm Neptune, slightly smaller than Neptune, but orbiting much closer to its star. It completes one orbit every 2.6 days, locked in a gravitational embrace that should have boiled away any water billions of years ago. The surface temperature reaches 800 degrees Fahrenheit, hot enough to melt lead, hot enough to make the planet glow with its own heat. And yet, deep within this world, there exists water in the form of ice. The pressure required to create this hot ice is almost incomprehensible. We're talking about pressures millions of times greater than what we experience at Earth's surface. Pressures so intense that they reshape the very structure of matter. Under these conditions, water molecules are forced into arrangements that simply cannot exist in our familiar world. The discovery of Gliese 436b changed how we think about planetary composition and the behavior of matter under extreme conditions. Before this world was discovered, we thought we understood the phases of matter: solid, liquid, gas, and plasma. But this planet introduced us to states of matter that exist only in the most extreme environments, states that blur the lines between our familiar categories. What makes this particularly haunting is that this hot ice makes up a significant portion of the planet's mass. We're not talking about a small pocket of exotic matter. We're talking about an entire world where the oceans are made of burning ice, where the very concept of liquid water becomes meaningless. What makes this particularly haunting is that this hot ice, we're not talking about a small pocket of exotic matter. We're not talking about a small pocket of exotic matter. We're talking about an entire world where the oceans are made of burning ice, where the very concept of liquid water becomes meaningless. The planet is essentially a giant ball of pressurized, superheated ice, orbiting through space like a cosmic impossibility. The planet's atmosphere is probably composed of hydrogen and helium, but it's the interior that truly defies comprehension. Layer upon layer of hot ice, compressed and heated, until the very concept of temperature becomes divorced from our understanding of phase changes. The core of the planet might be even more exotic, compressed into states of matter that we can barely imagine. Scientists believe that Gliese 436b formed much further from its star and then migrated inward over billions of years. As it moved closer to its star, the outer layers of gas were heated and expanded, but the core remained compressed enough to maintain its impossible state of hot ice. It's a world that has been slowly cooking for eons while remaining fundamentally frozen. The physics of this world challenge our most basic assumptions about habitability and planetary evolution. We look for liquid water as a sign of potential life. But what do we make of a world where water exists in a state that's simultaneously ice and fire? How do we categorize a planet where the familiar rules of chemistry have been rewritten by extreme pressure and temperature? There's something deeply unsettling about the idea that matter can exist in states so alien to our experience. Gliese 436b reminds us that the universe is filled with physical states that we can barely comprehend, worlds where the familiar becomes impossible and the impossible becomes routine. The planet continues its tight orbit around its star, a world of burning ice that has been defying our understanding of physics for billions of years. It's a reminder that the universe is far stranger than we imagine, filled with worlds that operate according to rules we're only beginning to understand. As we drift away from this world of impossible ice, we carry with us the knowledge that matter itself can be more flexible, more surprising, more alien than we ever suspected. Gliese 436b is a cosmic riddle that challenges us to expand our understanding of what's possible in a universe that delights in contradictions. 640 light-years away, in the constellation Pisces, there exists a world where the very air is made of vaporized metal, and the rain that falls from the sky is liquid iron. WASP 76b is a planet so impossibly hot that it has turned the periodic table into a weather system where elements we think of as solid and permanent become the stuff of clouds and precipitation. This world orbits its star so closely that it completes one full orbit in just 1.8 days. The planet is tidally locked, meaning one side permanently faces the star, while the other remains in eternal darkness. But it's this difference between day and night that creates the most spectacular and terrifying weather system ever discovered, a global circulation of metal vapor that transforms iron into rain. The silence around this world is the silence of physics being rewritten, of matter existing in states that shouldn't be possible, of ice that burns in the darkness of space. But the night side holds a different story. Here in the permanent darkness, temperatures drop to a merely hellish 2,700 degrees Fahrenheit. This temperature difference might seem small, but it's enough to cause the iron vapor to condense back into liquid form. Horsem. If you sambeth the Nized 7-2if, 7 Dauge, Inifient 7-2. The result is rain made of molten iron, droplets of liquid metal falling from the sky like some cosmic blacksmith's nightmare. Imagine standing on the Terminator line between day and night on this world. If such a thing were possible, you would witness the most spectacular and terrifying weather phenomenon in the known universe. On one side, you'd see a sky filled with invisible iron vapor, heated to temperatures that would instantly vaporize any material we know. On the other side, you'd watch as that vapor condenses into clouds of liquid metal, raining down molten iron in a perpetual metallic storm. On the day side of WASP 76b, temperatures reach over 4,000 degrees Fahrenheit, hot enough to vaporize iron. The very air becomes a mixture of hydrogen, helium, and metals in gaseous form. Iron atoms float through the atmosphere like invisible ghosts, heated to such extreme temperatures that they exist as individual atoms rather than the familiar solid metal we know on Earth. The discovery of iron rain on WASP 76b was made possible by studying the planet's spectrum as it transits in front of its star. Scientists noticed that iron absorption lines were present when they observed the planet's day side, but disappeared when they looked at the night side. This could only mean that iron was present as vapor on the day side, but absent from the night side atmosphere, because it was literally raining out of the sky. What makes this particularly haunting is the scale of this metal weather system. We're not talking about occasional iron showers. This is a planet-wide system where iron is constantly evaporating on one side and condensing on the other. The amount of iron in the atmosphere at any given time is staggering, enough to build thousands of skyscrapers floating as vapor in the alien sky. The physics of this world challenge our most basic understanding of weather systems. On Earth, we're familiar with the water cycle, evaporation, condensation, precipitation. But on WASP 76b, the same process occurs with iron. The day side acts as a giant evaporator, turning solid iron into vapor. The night side acts as a condenser, turning that vapor back into liquid metal that falls as rain. The planet's atmosphere is a cocktail of exotic chemistry that would be instantly lethal to any form of life we can imagine. Along with iron vapor, there are likely other metals in gaseous form, titanium, chromium, nickel, all floating through the atmosphere as invisible gases. The air itself would be poison, a mixture of vaporized metals that would kill any organism in seconds. The iron rain on WASP 76b probably doesn't fall gently like Earth rain. Given the extreme temperature differences and the planet's rapid rotation, the night side likely experiences violent storms of liquid metal, with winds carrying molten iron droplets at hundreds of miles per hour. It's a weather system that would make our most severe thunderstorms look like gentle spring showers. Scientists believe that WASP-76b might have originally been even larger, possibly a gas giant that lost its outer atmosphere to stellar radiation. What we see now might be the exposed core of a former giant planet, a world that has been stripped down to its metallic skeleton and then subjected to such extreme heat that even the skeleton has begun to vaporize. The planet's surface, if it has one, is probably covered in pools of liquid iron that have accumulated from billions of years of metallic precipitation. The landscape might be shaped by rivers of molten metal, lakes of liquid iron, and mountains formed from the gradual accumulation of metallic rain over geological time. The tidally locked nature of the planet means that this iron rain cycle is eternal and unchanging. The day side will always vaporize iron, the night side will always experience iron rain, and the terminator line will always be a zone of impossible weather where liquid metal falls from clouds of vaporized iron. There's something deeply unsettling about the idea that somewhere in the universe it has been raining liquid iron for longer than life has existed on Earth. The storms on WASP-76b have been raging since before our solar system formed, and they will likely continue long after our sun has died. As we drift away from this world of metallic weather, we carry with us the knowledge that the universe can take the most familiar elements and turn them into cosmic nightmares. WASP-76b reminds us that iron, the metal that makes up our blood, our tools, our civilization, can become the stuff of alien weather systems under the right conditions. In the constellation Cygnus, approximately 3,900 light-years from Earth, there exists a world that has witnessed the death of its star and somehow lived to tell the tale. Kepler-70b is a planet that survived the unsurvivable, orbiting the white dwarf remnant of a star that once expanded to engulf everything in its path. This is a world that has been through stellar hell and emerged as perhaps the most battle-scarred planet in the known universe. The silence around this world is broken only by the imagined sound of liquid iron falling like rain, a metallic percussion that has been playing for billions of years in the darkness of space. The planet's current orbit is so close to its star that it completes one full year in less than 6 hours. That's faster than most people's workday, faster than a long movie, faster than a single night's sleep. The world is locked in a gravitational dance so tight that it's essentially skimming the surface of its stellar parent, orbiting at a distance where the laws of physics become stretched to their limits. Wajases way, okanabiasa, wajases way ever two, wajases way ever two, wajases way ever two. The story of Kepler-70b reads like a cosmic epic of survival against impossible odds. Billions of years ago, this planet orbited a normal star, much like our sun. But stars are not eternal, and as its parent star aged, it began to run out of fuel. What happened next was one of the most violent transformations in the universe. The star expanded into a red giant, growing to hundreds of times its original size. During this red giant phase, the star's outer layers should have engulfed Kepler-70b completely. The planet should have been vaporized, torn apart by tidal forces, or simply consumed by the expanding stellar envelope. By all rights, this world should not exist. And yet here it is, orbiting the white dwarf remnant of its star every 5.76 hours, a testament to the universe's capacity for the impossible. The surface of Kepler-70b is probably unlike anything we can imagine. The planet receives so much radiation from its white dwarf companion that its day side reaches temperatures of over 12,000 degrees Fahrenheit, hot enough to vaporize any known material. The night side, permanently facing away from the star, might be slightly cooler, but we're talking about the difference between hellish and merely infernal. But how did Kepler-70b survive? Scientists believe the planet might have originally been a gas giant, possibly even larger than Jupiter. As the star expanded into a red giant, the planet's outer atmosphere was stripped away, layer by layer, until only a dense, rocky core remained. What we see today might be the naked heart of a former giant planet. a world that has been stripped down to its bare essentials by the most extreme cosmic forces. What makes this world particularly haunting is its isolation. Kepler-70b is completely alone in its system, the sole survivor of a stellar catastrophe that destroyed everything else. Any sibling planets, any moons, any debris that once shared this system was consumed by the red giant billions of years ago. The planet orbits through a cosmic graveyard, the only witness to a stellar death that reshaped an entire solar system. The physics of this world's existence challenge our understanding of planetary survival. The tidal forces from the nearby white dwarf should be tearing the planet apart, stretching it into an egg shape, or simply shredding it into cosmic debris. The fact that Kepler-70b maintains its structural integrity suggests that its core is incredibly dense, possibly made of materials compressed to states that exist nowhere else in the universe. The planet's surface is probably constantly reshaped by the intense radiation from its white dwarf companion. Materials that would be solid on Earth exist as gases here, creating an atmosphere of vaporized rock and metal. The landscape might be in constant flux, with mountains of diamond sublimating into gas during the day and condensing back into solid form on the night side. Scientists suspect that Kepler-70b might be composed largely of carbon and oxygen, the heavier elements that would have been concentrated in the core of a gas giant. Under the extreme conditions of its current orbit, these elements might exist in exotic states of matter, carbon compressed into diamond-like structures, oxygen in crystalline forms that don't occur naturally on Earth. The planet's rapid orbit means that it experiences time differently than we do. A year on Kepler-70b is shorter than a human workday, making the planet's existence feel frantic and desperate. It's racing around its star as if trying to outrun its own inevitable fate, locked in a gravitational embrace that will eventually spiral inward until the planet is completely consumed. There's something deeply melancholic about Kepler-70b's story. This is a world that has lost everything: its original atmosphere, its comfortable orbit, its stellar companion, its entire solar system. What remains is a stripped-down remnant of a former world, a planetary ghost that continues its death spiral around the corpse of its star. Yet, there's also something triumphant about this world's survival. Against all odds, against every prediction of planetary physics, Kepler-70b endured. It survived the death of its star, the destruction of its solar system, and the most extreme conditions imaginable. It's a testament to the resilience of matter itself, a reminder that sometimes the universe allows for survival in the most unlikely circumstances. In that posed, as we drift away from this battle-scarred world, we carry with us the knowledge that planets can survive stellar death, that worlds can endure the unsurvivable, and that sometimes the most damaged places in the universe are also the most extraordinary. The silence around Kepler-70b is the silence of a survivor, a world that has seen the end of everything and somehow found the strength to continue its eternal dance around the ruins of its star. 750 light-years from Earth, in the constellation Draco, there exists a world that seems to have been cut from the very fabric of darkness itself. TRES-2b is the darkest planet ever discovered, a world that reflects less light than coal, less than the blackest material we can imagine. This is a planet that absorbs light so completely that it appears as a hole in space, a cosmic void that challenges our understanding of how planets should behave. The planet orbits its star once every 2.5 days, locked in such a tight gravitational embrace that its day side reaches temperatures of over 1,800 degrees Fahrenheit. At these temperatures, the planet actually glows with its own heat, emitting a faint red light like a coal in a dying fire. This is the only reason we can see the planet at all, not because it reflects light, but because it's hot enough to produce its own dim illumination. When we think of planets, we imagine worlds that reflect at least some of the light that hits them. Even our own moon, which appears bright in our night sky, only reflects about 12% of the sunlight that reaches it. Mars reflects about 15%, Venus about 65%, but TRES-2b reflects less than 1% of the light that strikes its surface. It's darker than black paint, darker than soot, darker than anything we encounter in our daily lives. But what makes TRES 2b so impossibly dark? The answer lies in its atmosphere, a toxic cocktail of chemicals that seems designed to absorb light rather than reflect it. The planet's atmosphere likely contains vaporized sodium, potassium, and titanium oxide, compounds that are excellent at absorbing light across the visible spectrum. It's as if the planet has wrapped itself in a cloak of cosmic darkness, hiding from the light of its star. The surface of TRES 2b, if it has one, is probably invisible even to the planet's own star. The thick atmosphere of light-absorbing compounds would block virtually all starlight from reaching the surface, creating a world of perpetual darkness below the clouds. It's a planet where noon is as dark as midnight, where the concept of daylight becomes meaningless. Imagine approaching this world from space. As you draw closer, the planet wouldn't gradually become more visible, as we would expect. Instead, it would appear as a dark silhouette against the star field, a planetary shadow that seems to swallow light itself. The only indication of its presence would be the faint red glow of its own heat emission, like embers glowing in a sea of cosmic darkness. The atmospheric chemistry of TRES 2b is unlike anything we see in our solar system. The extreme heat has vaporized materials that would normally be solid rocks on Earth, creating clouds of metallic vapor that float through the atmosphere like dark phantoms. These clouds don't just block light, they actively absorb it, turning the planet into a cosmic sponge for electromagnetic radiation. The discovery of TRES 2b forced astronomers to reconsider their methods for detecting exoplanets. Traditional techniques rely on measuring the light reflected by planets, but TRES 2b reflects so little light that it's virtually invisible by conventional standards. Of astronomics. It was only detected through the transit method, by observing how it blocks starlight when it passes in front of its star. Scientists believe that the planet's darkness might be maintained by a complex feedback loop involving its atmospheric chemistry and temperature. The high temperature keeps metals vaporized in the atmosphere, which absorbs light and generates heat, which keeps the metals vaporized, which absorbs more light. It's a self-sustaining cycle of darkness that has been running for billions of years. What makes this world particularly unsettling is how it challenges our assumptions about planetary albedo and energy balance. Most planets reflect enough light to maintain some kind of equilibrium between absorbed and reflected energy, but TRES 2b seems to violate this principle, absorbing almost everything and reflecting almost nothing. It's a cosmic anomaly that shouldn't exist according to our models of planetary behavior. There's something deeply unsettling about the idea that there are worlds out there that exist in states of near-perfect darkness. TRES 2b reminds us that the universe can create conditions so extreme that they seem to defy the very concept of visibility. It's a world that has achieved a kind of cosmic invisibility, hiding in plain sight among the stars. The planet's darkness is so complete that it approaches the theoretical limits of light absorption. If TRES 2b were any darker, it would violate the laws of physics. It's a world that has pushed the boundaries of what's possible in terms of planetary opacity, creating a kind of cosmic event horizon where light goes in but never comes out. As we contemplate this world of impossible darkness, we're forced to confront the limitations of our visual understanding of the universe. We're creatures of light, evolved to see and understand the world through electromagnetic radiation. But TRES 2b exists in a state that's almost entirely invisible to us, a reminder that there are worlds out there that exist beyond our sensory perception. 40 light-years from Earth, in the constellation Cancer, there exists a world that transforms our most precious materials into instruments of cosmic torture. 55, Cancer E, is a planet where the very ground beneath your feet would be made of diamond, where the air rains liquid carbon, and where the most valuable substance on Earth becomes the foundation of an incomprehensible hell. As we drift away from this world of cosmic darkness, we carry with us the knowledge that there are planets out there that exist in states of near-perfect opacity, worlds that have become holes in the visible universe, reminders that sometimes the most extraordinary things are the ones we can barely see. The silence around TRES 2b is not just the silence of space, It's the silence of a world that has hidden itself from the light of its star, a planet that has chosen darkness over illumination, absorption over reflection. The planet's carbon-rich composition likely results from its formation in a disk of material unusually rich in carbon and poor in oxygen. While Earth and most rocky planets are made primarily of silicate rocks, 55 Centauri formed from a different recipe entirely. The result is a world where diamond isn't a rare gemstone found in small deposits. It's the primary building material of the planet itself. This world orbits its star so closely that it completes one full orbit in just 18 hours. The planet is tidally locked, with one side permanently facing its star, while the other remains in eternal darkness. But unlike other tidally locked worlds we've encountered, 55 Cancroier has a composition that makes it unique among all known planets. It's made largely of carbon, compressed by billions of years of pressure into crystalline structures that would make it the most valuable world in the universe if it weren't also the most lethal. But this isn't the kind of diamond we know from jewelry stores. The diamonds on 55 Cancroier exist under conditions so extreme that they challenge our understanding of how matter behaves. The surface temperature reaches over 3,000 degrees Fahrenheit, hot enough to melt lead and copper. At these temperatures, the diamond surface doesn't gleam with the brilliant sparkle we associate with gemstones. Instead, it probably glows with its own heat, creating a world that literally burns with crystalline fire. The atmospheric conditions on 55 Cancroier are equally nightmarish. The extreme heat has vaporized carbon from the planet's surface, creating an atmosphere rich in carbon vapor. As this vapor rises into the slightly cooler upper atmosphere, it condenses into droplets of liquid carbon that fall back to the surface as rain. It's a carbon cycle that mirrors Earth's water cycle, but with liquid carbon instead of water. The physics of this world challenge our assumptions about planetary geology and atmospheric chemistry. On Earth, we're familiar with the rock cycle. Rocks are formed, weathered, and reformed through geological processes. But on 55 Centauri E, the same processes occur with carbon. Diamond is eroded by the extreme heat, vaporized into the atmosphere, and then deposited again as new diamond formations through carbon rain. Imagine standing on the diamond surface of this world. If such a thing were possible, the ground beneath your feet would be made of the same material that represents ultimate luxury on Earth, but compressed and heated to states that would kill you instantly. The air would be thick with carbon vapor, unbreathable and toxic. Above you, clouds of liquid carbon would form and dissolve, occasionally releasing showers of molten carbon that would add new layers to the diamond landscape. Scientists estimate that 55 Cancroier might contain more diamond than the total mass of Earth. We're talking about a world where the most precious material in human civilization exists in quantities that would make it as common as sand. The entire planet is essentially a massive diamond floating through space, heated to temperatures that would vaporize most other materials. What makes this world particularly haunting is how it perverts something we associate with beauty and value. Diamonds on Earth are symbols of love, commitment, and luxury, but on 55 Cancroier, diamond becomes a hostile environment, a material that exists in such extreme conditions that it would kill any living thing that encountered it. It's a world that takes our most precious substance and turns it into a weapon of cosmic destruction. The planet's diamond composition also affects its thermal properties in unusual ways. Diamond is an excellent conductor of heat, which means that temperature differences across the planet's surface are probably less extreme than we would expect. Heat from the day side is efficiently conducted through the diamond substrate to the night side, creating a world where even the dark side glows with transferred heat. The planet's rapid orbit means that the diamond rain cycle occurs on a timescale that's almost incomprehensible. In the time it takes you to read this sentence, the planet has moved measurably in its orbit, and the carbon rain has fallen and vaporized and fallen again countless times. It's a world where geological processes that take millennia on Earth happen in hours or days. The discovery of 55 Cancroier changed how we think about planetary composition and the diversity of worlds that can exist in the universe. Before this planet was discovered, we assumed that rocky planets would be made primarily of silicate rocks like Earth. But 55 Cancri showed us that planets can be made of entirely different materials, creating worlds with properties we never imagined possible. There's something deeply ironic about the fact that 55 Cancri, a world made of the most precious material on Earth, is also one of the most hostile environments in the known universe. It's a reminder that value and beauty are relative concepts, that what we treasure in one context can become deadly in another. As we drift away from this world of burning diamonds, we carry with us the knowledge that the universe can take our most precious materials and transform them into cosmic nightmares. 55 Cancri reminds us that even diamond, the hardest natural substance we know, can become the foundation of a world so hostile that it redefines our understanding of what's possible in the realm of planetary hell. 1,000 light-years from Earth, in the constellation Scariest, there exists a world that challenges our most fundamental assumptions about how planetary systems should behave. WASP-17b is a planet that orbits its star in the wrong direction, spinning backwards through space in a cosmic dance that suggests a violent and chaotic past. This is a world that has somehow survived having its entire orbital motion reversed, a testament to the universe's capacity for gravitational violence. The silence around this world is broken only by the imagined sound of liquid carbon falling like rain onto a surface of burning diamond, a crystalline percussion that has been playing for billions of years in the darkness of space. Most planets in our solar system orbit the Sun in the same direction that the Sun rotates, a pattern that reflects the orderly formation of our solar system from a rotating disk of gas and dust. This is the natural order of things, the way planetary systems are supposed to work. But WASP-17b breaks this rule in the most dramatic way possible. It orbits its star in the opposite direction, a phenomenon that astronomers call retrograde motion. The implications of this backwards orbit are staggering. For a planet to end up in retrograde motion, something catastrophic must have happened in its past. The most likely explanation is that WASP-17b was involved in a gravitational encounter so violent that it literally flipped its orbit, sending it spinning backwards through space like a cosmic billiard ball that's been struck by some unimaginable force. Scientists believe that this gravitational catastrophe probably involved another planet, possibly even another star. In the early days of the WASP-17 system, the planets might have been arranged in a more conventional pattern, but then something went wrong, perhaps a close encounter with a passing star. A gravitational interaction with a massive planet that had migrated inward from the outer system. The result was a cosmic collision, or near miss, that sent WASP-17b careening backward through space. The planet itself bears the scars of this violent past. WASP-17b is what astronomers call a puffy planet. It has a mass similar to Jupiter, but is nearly twice as large. This unusual size suggests that the planet has been heated and inflated by its chaotic orbital history. The gravitational violence that reversed its orbit also pumped enormous amounts of energy into the planet, causing it to swell like a cosmic balloon. What makes this world particularly unsettling is the implications for its formation and evolution. WASP-17b likely started life as a normal planet in a normal orbit. It might have had moons, rings, or even a stable climate. But the gravitational catastrophe that flipped its orbit would have destroyed all of these features. Any moons would have been torn away or sent spinning into space. Any rings would have been shattered and scattered. The planet, as we see it today, is essentially a survivor of cosmic violence, a world that has been fundamentally transformed by forces beyond imagination. The backwards orbit of WASP-17b creates unique tidal forces that further distort the planet's shape and internal structure. Instead of the usual pattern of tidal heating that occurs when a planet orbits in the same direction as its star's rotation, WASP-17b experiences a kind of reverse tidal effect. The planet and its star are locked in a gravitational tug-of-war that plays out in the wrong direction, creating stresses and strains that don't exist anywhere else in the known universe. The discovery of WASP-17b changed how we think about planetary system evolution. Before this world was discovered, we assumed that planets mostly stayed in the orbits where they formed, with only minor adjustments over time. But WASP-17b showed us that planetary systems can be far more dynamic and violent than we previously imagined. Planets can be scattered, reversed, and fundamentally transformed by gravitational interactions. The planet's retrograde orbit also affects its atmospheric dynamics in unique ways. The interaction between the planet's rotation and its backwards orbital motion creates complex atmospheric flows that don't exist on any other known world. The planet's weather systems are driven by forces that are literally backwards compared to every other planet we've studied. The process of orbital reversal would have been incredibly violent and chaotic. The planet would have experienced extreme tidal forces as its orbit was gradually twisted and flipped. The surface would have been subjected to gravitational stresses that would have reshaped the landscape. If there was a solid surface to reshape, the atmosphere would have been stirred and heated by the orbital chaos, creating weather patterns unlike anything we can imagine. The backwards orbit of WASP-17b is also gradually decaying. The planet is slowly spiraling inward toward its star, suggesting that its current orbit is not stable over geological timescales. This world that survived one cosmic catastrophe is now heading toward another, as its backwards dance with its star inevitably leads to a final fatal encounter. There's something deeply unsettling about the idea that planetary systems can be so fundamentally disrupted. WASP-17b reminds us that the orderly, stable solar system we live in is not the universal norm. Out there in the galaxy, there are worlds that have been scattered and reversed by gravitational violence, planets that orbit backwards through space as monuments to cosmic chaos. As we drift away from this world of reversed motion, we carry with us the knowledge that planetary systems can be far more violent and chaotic than we ever imagined. WASP-17b is a reminder that the universe is filled with worlds that have been fundamentally transformed by gravitational violence, planets that spin backwards through space, as testament to the cosmic forces that can reshape entire solar systems. 200 light-years from Earth, in the constellation Cygnus, there exists a world that at first glance seems to have stepped out of science fiction. Kepler-16b orbits not one star but two, creating a landscape where twin suns rise and set in an alien sky. This might sound romantic, even beautiful, but the reality of this binary star system creates one of the most chaotic and hostile environments ever discovered. A world where the very concept of stable seasons becomes meaningless. The silence around WASP-17b is the silence of a world that has survived the unsurvivable, a planet that continues its backwards dance through space as a monument to the universe's capacity for gravitational chaos. Kepler-16b was the first confirmed planet discovered orbiting two stars, a configuration that astronomers call a circumbinary planet. The two stars at the heart of this system are locked in their own gravitational dance, orbiting each other every 41 days. One star is roughly the size of our Sun, while the other is smaller and cooler, creating an uneven binary pair that pumps irregular amounts of heat and radiation into the surrounding space. This irregular heating pattern would create weather systems unlike anything we can imagine. The planet's atmosphere would be in constant flux, with temperature differences driving winds and storms that change direction and intensity based on the ever-changing positions of the two stars. It would be a world of perpetual meteorological chaos, where the very concept of predictable weather becomes impossible. What makes Kepler-16b particularly terrifying is the radiation environment created by the binary star system. The two stars don't just provide heat and light, they also interact with each other in ways that generate powerful magnetic fields and stellar flares. Carrefour, magnetic fields and stellar flares. De intergalvna bosammindias, imoistin bildemadias fars. When the stars are aligned in certain configurations, they can create magnetic field interactions that launch enormous amounts of radiation into space. Any atmosphere on the planet would be constantly bombarded by these irregular radiation storms. The planet itself orbits both stars at a distance that places it just outside what would normally be considered the habitable zone. But in a binary star system, the concept of a habitable zone becomes almost meaningless. The two stars are constantly changing their relative positions, creating a complex pattern of heating and cooling that would make stable climate impossible. Sometimes both stars are on the same side of the planet, creating periods of intense heat. Other times they're on opposite sides, creating more moderate temperatures. And sometimes one star is hidden behind the other, creating periods of relative cooling. The gravitational environment around Kepler-16b is equally chaotic. The planet experiences gravitational forces not just from one star, but from two. And these forces are constantly changing as the stars orbit each other. The result is a complex gravitational dance that would make the planet's orbit unstable over long timescales. The planet might be slowly spiraling inward or outward, or its orbit might be gradually changing shape in ways that would make long-term survival impossible. The planet's size and composition add another layer of complexity to its hostile environment. Kepler-16b is roughly the size of Saturn, making it a gas giant with no solid surface. But unlike Saturn, which orbits a single, stable star, this world exists in a constant state of atmospheric turmoil. The irregular heating from the binary stars would create massive atmospheric storms, with cloud formations and wind patterns that change based on the complex orbital mechanics of the three-body system. The discovery of Kepler-16b challenged our understanding of planetary formation in binary star systems. Before this world was discovered, many astronomers thought that stable planets couldn't form around close binary stars. The gravitational chaos of the two stars should have prevented any solid material from accumulating into a planet. But Kepler-16b proved that planets can form even in the most gravitationally chaotic environments, though the resulting worlds are far from hospitable. The planet's atmosphere, if it has retained one, would be in constant turmoil. The irregular heating from the binary stars would create massive convection patterns, with material from the planet's interior being dragged up to the surface and then blasted back down by radiation storms. It would be a world where the very concept of atmospheric layers becomes meaningless, where the boundary between space and atmosphere is constantly shifting. The day-night cycle on Kepler-16b would be unlike anything we experience on Earth. Sometimes the planet would experience double sunset as both stars set simultaneously. Other times, one star would set while the other remained in the sky, creating a kind of perpetual twilight. The planet's seasons would be determined not by its axial tilt, but by the complex orbital mechanics of the binary star system, creating irregular periods of heat and cold that would make agricultural civilization impossible. What's particularly unsettling about Kepler-16b is how it destroys our romantic notions of binary star systems. Science fiction has long portrayed worlds with two suns as exotic but potentially habitable, places where alien civilizations might develop under the light of twin stars. But the reality of Kepler-16b shows us that binary star systems are more likely to create worlds of chaos and instability than romantic alien paradises. The silence around Kepler-16b is broken only by the imagined howl of winds driven by the irregular heating of twin stars, a sound that has been playing for millions of years in the chaos of binary space. The orbital mechanics of the Kepler-16 system also create unique eclipse patterns. The planet regularly passes behind one or both of its stars, creating complex shadow patterns that would make the concept of day and night almost meaningless. An observer on the planet would experience regular periods of partial or total eclipse, with the light levels changing dramatically based on the relative positions of the three bodies. As we drift away from this world of binary chaos, we carry with us the knowledge that some of the most beautiful astronomical configurations, twin stars dancing in space, can create some of the most hostile environments for planetary development. Kepler-16b reminds us that the universe often takes our most romantic notions and transforms them into cosmic nightmares. At these temperatures, the very concept of atmospheric layers breaks down. On Earth, we have distinct atmospheric zones: the troposphere where we live, the stratosphere above that, and the mesosphere and thermosphere extending into space. Each layer has its own temperature profile and chemical composition. But on WASP 121b, the heat is so intense that these boundaries become meaningless. The entire atmosphere becomes a single chaotic zone where the laws of chemistry are rewritten by extreme temperature. This planet orbits its star at a distance so close that it completes one full orbit in just 30 hours. The gravitational forces are so intense that the planet is being stretched into an egg shape, with the pointed end facing its star like a cosmic teardrop frozen in time. But it's the temperature of this world that truly defies comprehension. The day side reaches over 4,600 degrees Fahrenheit, making it one of the hottest planets ever discovered. 850 light-years from Earth, in the constellation Puppis, there exists a world where the very atmosphere is being torn apart by heat so intense that it challenges our understanding of what an atmosphere can be. WASP 121b is a planet so impossibly hot that its upper atmosphere is literally being destroyed, with metals like magnesium and iron floating as vapor in what should be the cold, thin layers of space above the world. But the horror doesn't end there. The planet's atmosphere is so hot that it's literally escaping into space. The upper atmospheric layers are being heated to temperatures that exceed the planet's escape velocity, meaning that the atmosphere is being constantly stripped away and lost to space. This process, called atmospheric escape, is happening so rapidly that the planet is losing its atmosphere at a rate that would completely strip it away in a relatively short time by astronomical standards. The atmospheric escape from WASP 121b creates a comet-like tail of hot gas that extends behind the planet as it orbits its star. This tail is made up of the planet's own atmosphere, heated to such extreme temperatures that it's being blown away by the stellar wind. The planet is essentially being evaporated by its own star, losing parts of itself with each orbit in a process that will eventually leave nothing but a bare core. The upper atmosphere of WASP 121b contains metals that should never exist as gases. Magnesium and iron, elements that we think of as solid metals, are floating as vapor in the planet's stratosphere. These metals are being heated to such extreme temperatures that they exist as individual atoms, stripped of their electrons, and turned into a kind of metallic plasma that drifts through the upper atmosphere like cosmic smoke. What makes this particularly terrifying is the implication for the planet's evolution. WASP 121b is caught in a death spiral, WASP losing its atmosphere to space while being heated to ever more extreme temperatures. The planet that we see today is probably much smaller and less massive than it was when it first formed. It's a world that's being slowly consumed by its own star, turned into fuel for the stellar engine that powers its destruction. The discovery of metal vapors in the stratosphere of WASP 121b was made possible by studying the planet's transmission spectrum, the light that passes through the planet's atmosphere as it transits in front of its star. Scientists found the unmistakable signatures of magnesium and iron in the upper atmosphere, metals that should condense into solid form at the low pressures found in the stratosphere of any normal planet. The atmospheric dynamics of WASP 121b create weather patterns that are unlike anything we can imagine. The extreme temperature differences between the day and night sides drive supersonic winds that carry the metal vapors around the planet. These winds are so hot that they glow with their own light, creating a planet where the air itself is luminous. The sky on WASP 121b would be filled with glowing streams of vaporized metal, creating an aurora-like display that never ends. The planet's magnetic field, if it has one, is probably being constantly disrupted by the intense stellar radiation and the planet's own atmospheric escape. The magnetic field lines are likely being twisted and broken by the flow of escaping atmosphere, creating a chaotic magnetic environment that would make any kind of stable atmospheric structure impossible. The planet's stratosphere is also being affected by the intense ultraviolet radiation from its star. This radiation is so intense that it's breaking apart molecules in the upper atmosphere, creating a chemical soup of atomic fragments that can't exist under normal conditions. The stratosphere has become a kind of chemical factory, constantly producing and destroying molecules in reactions powered by stellar radiation. The temperature profile of WASP-121b's atmosphere is completely inverted compared to Earth. While Earth's stratosphere is cooler than the layers below it, WASP-121b's stratosphere is actually hotter than the lower atmosphere. This creates a situation where the normal circulation patterns of atmospheric gases are completely reversed, with hot gases rising from the stratosphere and cooler gases sinking from below. Scientists believe that WASP-121b represents an extreme example of a process that affects many hot planets. The atmospheric escape we see on this world is probably happening on many other close-in exoplanets, just not to such an extreme degree. WASP-121b is showing us the end result of this process, a world where the atmosphere has been heated to the point where it can no longer remain bound to the planet. As we drift away from this world of dying atmosphere, we carry with us the knowledge that planets can be so hot that their very atmospheres are destroyed. WASP-121b reminds us that the universe can create conditions so extreme that they challenge the very concept of what constitutes a planet's atmosphere. The silence around WASP-121b is the silence of a world losing its voice, an atmosphere being stripped away into space one molecule at a time. 202 light-years from Earth, in the constellation Aquarius, there exists a world where the very concept of an ocean takes on a nightmarish new meaning. K2141b is a planet where the day side is covered by an ocean of molten rock that stretches 3,000 kilometers deep, while supersonic winds of vaporized rock create weather patterns that would make the most violent Earth storms seem like gentle breezes. The day side of K2141b reaches temperatures of over 5,400 degrees Fahrenheit, hot enough to vaporize rock and turn solid stone into gas. At these temperatures, the surface doesn't just melt, it becomes a roiling ocean of liquid rock that behaves like water on Earth. This magma ocean is deeper than the distance from New York to Los Angeles, a vast sea of molten stone that stretches from horizon to horizon under a sky filled with rock vapor. This world orbits its star so closely that it completes one full orbit in just 6.7 hours, making its year shorter than a human workday. The planet is tidally locked, with one side permanently facing the star, while the other remains in eternal darkness. Whole so, seven seth, wado ford. But it's the temperature difference between these two sides that creates the most spectacular and terrifying geological processes ever discovered. The night side of Kev-2141b tells a different story. Here, in the permanent darkness, temperatures drop to a merely hellish 3,000 degrees Fahrenheit. This temperature difference is enough to cause the rock vapor that rises from the magma ocean to condense and fall as rain. But this isn't gentle precipitation. It's a torrential downpour of liquid rock with droplets of molten stone falling from the sky like a geological apocalypse. The atmospheric circulation on K2141b creates winds that reach speeds of over 3,000 miles per hour. These winds are made of vaporized rock, sodium, silicon, oxygen, and other elements that make up the planet's surface, all suspended in the atmosphere as a toxic superheated gas. The winds carry this rock vapor from the day side to the night side, where it condenses and falls as the liquid rock rain that feeds back into the magma ocean. But the magma ocean isn't static. Like Earth's oceans, it's driven by powerful currents and circulation patterns. The extreme temperature differences between the day and night sides create massive convection currents that carry molten rock from the depths to the surface and back again. These currents are driven by heat from the planet's star, creating a circulation system that's been running for millions of years. The geology of K2-141b is unlike anything we see on Earth. The planet's surface is in constant flux, with the magma ocean constantly reshaping the landscape. Islands of cooler rock might briefly form and then dissolve back into the molten sea. Mountain ranges could be built and destroyed in matters of hours, erased by the constant circulation of the magma ocean. Imagine standing on the shoreline of this magma ocean. If such a thing were possible, you would see waves of molten rock stretching to the horizon, each wave glowing with its own internal heat. The sky above would be filled with clouds of vaporized stone, occasionally lit by lightning that crackles through the mineral-rich atmosphere. The very air would be unbreathable, a toxic mixture of rock vapor that would kill any living thing in seconds. The planet's magnetic field, if it has one, is probably being constantly disrupted by the circulation of the magma ocean. The movement of electrically conductive molten rock creates complex magnetic field patterns that change as the ocean currents shift. This would create a chaotic magnetic environment that would make any kind of stable atmospheric structure impossible. Scientists believe that K2-141b represents an extreme example of what happens when a rocky planet is subjected to intense stellar heating. The magma ocean is probably the result of billions of years of extreme heat from the planet's star, gradually melting and vaporizing the surface until it reached its current state. The planet is essentially a geological laboratory, showing us what happens when rock is subjected to the most extreme conditions imaginable. The circulation patterns of the magma ocean probably create different zones with different chemical compositions. Areas where the ocean is deeper might have different mineral compositions than areas where it's shallower. The constant circulation would create a kind of planetary mixing process, constantly redistributing the chemical elements that make up the planet's surface. The atmospheric composition of K2-141b is dominated by the elements that make up rock: silicon, oxygen, magnesium, iron, and other metals, all existing as vapor in the planet's atmosphere. This creates a sky that's filled with the building blocks of planets, suspended as gas in an atmosphere that's hot enough to melt steel. The discovery of K2-141b changed how we think about planetary geology and the behavior of rock under extreme conditions. Before this world was discovered, we thought of rock as something fundamentally solid, something that might melt under extreme conditions but would still behave as a solid material. But K2-141b shows us that rock can behave like a fluid, creating ocean-like bodies that follow the same circulation patterns as water on Earth. The planet's rapid rotation creates additional complexity in the magma ocean's circulation. The 6.7-hour day creates Coriolis effects that would influence the ocean currents, creating spiral patterns and vortices in the molten rock. These patterns would be visible from space as swirling formations in the magma ocean, like hurricanes made of liquid stone. As we drift away from this world of molten stone, we carry with us the knowledge that planets can exist in states that challenge our most basic assumptions about geology and atmospheric science. K2-141b reminds us that the universe can take the most familiar materials and subject them to conditions so extreme that they become alien and terrifying. WASP-189b orbits its star once every 2.7 days, locked in a gravitational embrace so tight that the planet's day side reaches temperatures of over 7,000 degrees Fahrenheit. To put this in perspective, this is hotter than the surface of many red dwarf stars, hotter than the sun's photosphere, hot enough to ionize atoms and turn matter into plasma. This is a world where the very concept of solid matter becomes meaningless. The silence around K2-141b is broken only by the imagined roar of supersonic winds carrying vaporized rock across a world where the very ground has become an ocean of liquid stone. 322 light-years from Earth, in the constellation Libra, there exists a world that pushes the very boundaries of what we can call a planet. Hi, what Hawsbury, what fine into WASP 189b is so hot that it challenges our understanding of matter itself. A world where temperatures reach levels that would make some stars seem cool by comparison. This is a planet where the familiar states of matter break down, where the very atoms that make up the world are torn apart by heat so intense that it defies comprehension. At the temperatures found on WAT 189b, hot familiar rules of chemistry break down completely. Molecules can't exist. They're instantly torn apart by the thermal energy. Even atoms struggle to maintain their structure, with electrons being stripped away to create a plasma of charged particles. The planet's atmosphere, if it can still be called that, is essentially a sea of plasma, a fourth state of matter that exists nowhere naturally on Earth. The planet's composition becomes almost academic at these temperatures. Whether WASP 189b is made of rock, ice, or gas matters little when the temperature is high enough to vaporize any known material. The planet is likely surrounded by a thick atmosphere of ionized gas, possibly including the vaporized remains of its original solid surface. It's a world where the very concept of surface composition becomes meaningless. The planet orbits an A-type star, a stellar giant that burns much hotter and brighter than our sun. This star is so hot that it glows with an intense blue-white light, Holberg shout, pumping enormous amounts of energy into the surrounding space. The planet receives over 3,000 times more energy from its star than Earth receives from the sun, creating a thermal environment that approaches the conditions found in stellar atmospheres. The planet's magnetic field, if it has one, is probably being constantly disrupted by the plasma environment. The charged particles in the atmosphere interact with magnetic fields in complex ways, creating a chaotic electromagnetic environment that would make any kind of stable atmospheric structure impossible. The planet might be surrounded by a kind of permanent aurora, as charged particles interact with whatever magnetic field the planet can maintain. What makes WASP 189b particularly terrifying is how it challenges our understanding of planetary formation and evolution. This world likely started as a gas giant, possibly similar to Jupiter, but the intense radiation from its star has stripped away its outer layers, leaving behind a superheated core that's being slowly evaporated into space. The planet is essentially being turned into fuel for its star's energy output. The atmospheric dynamics of WASP 189b create weather patterns that exist at the edge of physics. The extreme temperature differences between the day and night sides drive winds that reach speeds of thousands of miles per hour. But these aren't winds of air or gas. They're winds of plasma, streams of ionized particles that race around the planet at velocities that would make the fastest Earth winds seem motionless. The discovery of WASP 189b was made possible by studying the planet's thermal emission, the heat that it radiates into space. Scientists found that the planet is so hot that it glows with its own light, visible to our telescopes as a point of heat against the cosmic background. The planet is essentially a miniature star, glowing with thermal energy that makes it visible across hundreds of light years. The planet's orbital characteristics suggest that it's caught in a death spiral, slowly losing mass to space as its atmosphere is stripped away by the intense stellar radiation. The planet is probably much smaller now than it was when it first formed, reduced to a fraction of its original size by billions of years of stellar bombardment. It's a world that's being slowly consumed by its own star. The planet's atmosphere contains elements that should never exist as gases at normal planetary temperatures. Iron, magnesium, and other metals are floating as vapor in the planet's atmosphere, along with more exotic elements that have been vaporized by the extreme heat. The atmospheric composition reads like a list of the periodic table, with elements existing in states that can only be achieved under the most extreme conditions. The temperature gradient on WASP 189b creates unique atmospheric phenomena. The day side is hot enough to ionize heavy metals, while the night side, though still incredibly hot, might be cool enough for some molecules to briefly exist before being swept back to the day side by the planet's circulation. This creates a kind of molecular assembly line, where complex particles are constantly being created and destroyed by the planet's thermal environment. The planet's proximity to its star also creates extreme tidal effects. The gravitational forces are so strong that the planet is probably being stretched and compressed with each orbit, generating additional heat through tidal heating. This internal heating adds to the already extreme temperatures, creating a world that's being cooked from both outside and inside. Scientists believe that WASP-189b represents the end stage of planetary evolution for worlds that orbit too close to their stars. This is what happens when a planet is subjected to stellar radiation, so intense that it begins to break down at the atomic level. The planet is showing us the ultimate fate of worlds that venture too close to their parent stars. As we drift away from this world of impossible heat, we carry with us the knowledge that planets can exist in states that challenge the very definition of matter. WASP-189b reminds us that the universe can create conditions so extreme that they blur the line between planets and stars, between matter and energy, between existence and destruction. The silence around WASP-189b is the silence of matter being torn apart and rebuilt, of a world that exists at the very edge of what physics allows. 300 light-years from Earth, in the constellation Cygnus, there exists a world that represents perhaps the cruelest trick the universe has ever played on our hopes for finding life beyond our solar system. Kepler 1649c appears to be almost exactly like Earth, similar in size, similar in temperature, orbiting in the habitable zone of its star, where liquid water could exist. For a brief moment after its discovery, this world seemed like it might be our planet's twin, a place where life could flourish. But the more we learn about Kepler 1649c, the more we realize that it's not a haven for life. It's a world caught in a cycle of sterilization, so regular and so violent that it makes the planet uninhabitable despite its Earth-like appearance. Kepler 1649c orbits a red dwarf star, one of those small, cool stars that burn for trillions of years and seem perfect for hosting life. The planet sits squarely in the habitable zone, that precious distance from its star, where temperatures are just right for liquid water to exist on the surface. It's roughly the same size as Earth, suggesting that it might have a similar composition and perhaps even a similar atmosphere. By every measure we use to evaluate habitability, Kepler 1649c should be a world where life could emerge and evolve. The flares from Kepler 1649c star are estimated to be hundreds of times more powerful than the strongest solar flares ever recorded. When these flares occur, they flood the planet with deadly radiation that would strip away its atmosphere molecule by molecule. The planet's surface would be bombarded with high-energy particles that would break apart the complex molecules necessary for life, sterilizing the surface and making it uninhabitable for any organism we can imagine. But red dwarf stars harbor a terrible secret that makes them far more dangerous than they appear. These seemingly gentle stars are prone to massive stellar flares, explosions of radiation, and charged particles that can increase the star's brightness by orders of magnitude in just minutes. These flares are not occasional events like the solar flares we see from our sun. They're regular, violent outbursts that can happen multiple times per day, turning the star into a cosmic lighthouse of destruction. The discovery of Kepler 1649c was initially celebrated as a major breakthrough in the search for habitable worlds. Here was a planet that seemed to check all the boxes: the right size, the right temperature, the right distance from its star. But as astronomers learned more about red dwarf stars and their tendency toward violent flares, the excitement turned to disappointment, and then to a kind of cosmic horror as we realized that this Earth-like world was actually a death trap. What makes this particularly cruel is the timescale involved. These sterilizing flares don't happen just once. They happen regularly, perhaps multiple times per week. Even if life somehow managed to evolve during a quiet period, the next flare would reset the evolutionary clock, destroying any complex organisms and breaking down the chemical building blocks of life. The planet is caught in a perpetual cycle of biological destruction, where life can never get a foothold because the next sterilizing event is always just around the corner. The planet's proximity to its star, necessary for it to be in the habitable zone of a cool red dwarf, makes it even more vulnerable to these flares. Kepler 1649c orbits its star once every 19.5 days, close enough that the stellar radiation during flares would be intense enough to strip away the planet's atmosphere over geological timescales. The planet is probably losing its atmosphere to space, slowly being reduced to a bare, airless rock by the constant bombardment. The atmospheric composition of Kepler 1649c is probably very different from Earth's, despite the planet's Earth-like appearance. The constant bombardment by stellar flares would create a chemical environment unlike anything on our planet. The radiation would break apart water molecules, creating a hydrogen-rich atmosphere that would be gradually lost to space. Oxygen would be stripped away, nitrogen would be ionized, and any complex molecules would be destroyed. What's particularly unsettling about Kepler 1649c is how it represents the false promise of red dwarf systems. About 75% of all stars in our galaxy are red dwarfs, and many of them have planets in their habitable zones. For a while, astronomers thought that these systems might be the most common places to find life in the universe, but the discovery of the violent nature of red dwarf flares suggests that most of these potentially habitable worlds are actually uninhabitable death traps. The planet's magnetic field, if it has one, is probably being constantly disrupted by the stellar flares. Earth's magnetic field protects us from solar radiation, but the flares from red dwarf stars are so intense that they would overwhelm any planetary magnetic field. The planet's magnetosphere would be compressed and possibly stripped away entirely, leaving the surface exposed to the full force of stellar radiation. The search for life around red dwarf stars has been fundamentally changed by our understanding of stellar flares. Kepler 1649c represents thousands of potentially habitable worlds that have been revealed to be uninhabitable, a cosmic disappointment that has reshaped our understanding of where life might exist in the universe. As we drift away from this world of false hope, we carry with us the knowledge that appearances can be deceiving on a cosmic scale. Kepler 1649c reminds us that the universe is filled with worlds that seem perfect for life, but are actually perfect for death. Planets that offer the promise of habitability while delivering only sterilization. The planet's surface, if it retains any atmosphere at all, is probably a hellscape of radiation-damaged rock and chemically altered minerals. The regular sterilizing flares would have changed the very composition of the surface rocks, creating a world that looks nothing like the Earth-like planet we might imagine. It's a world where the promise of habitability has been turned into a guarantee of sterility. WASP-18b is what astronomers call a hot Jupiter, a massive gas giant that orbits incredibly close to its star. The planet is roughly 10 times more massive than Jupiter, but it completes one orbit in just 22.6 hours. This proximity creates a gravitational relationship so intense that it's slowly destroying both the planet and its star. The planet is gradually spiraling inward, while the star is being forced to rotate faster and faster to keep up with its doomed companion. 325 light-years from Earth, in the constellation Phoenix, there exists a world that is racing toward its own destruction with such inevitability that we can calculate almost exactly when it will die. WASP-18b is a planet caught in a death spiral, slowly spiraling inward toward its star in a cosmic dance that will end in complete annihilation in less than 1,000,000 years. Is this 1,000,000 years? This is a world where we can literally watch the countdown to planetary destruction, measured not in human lifetimes, but in astronomical moments. The silence around Kepler 1649c is the silence of a world that could have been, a planet that will never fulfill its promise because its star won't let it. The process is remarkably efficient and utterly inexorable. Scientists have calculated that WASP-18b is losing orbital energy at a rate that will cause it to spiral into its star in approximately 650,000 years. In cosmic terms, this is essentially instantaneous, barely a blink of an eye in the life of a star. The planet is living on borrowed time, racing toward a destruction that is as certain as it is calculable. The physics of this death spiral are both elegant and terrifying. As WASP-18b orbits its star, it creates tidal bulges in the star's surface, just as our moon creates tides in Earth's oceans. But while Earth's tides are gentle and predictable, the tidal forces created by WASP-18b are catastrophic. The planet is so massive and so close to its star that it's literally deforming the star's surface, creating tidal bulges that rise and fall with each orbit. These tidal forces extract energy from the planet's orbital motion, causing it to slowly spiral inward. Each orbit brings the planet slightly closer to its star, and each closer orbit makes the tidal forces stronger, accelerating the spiral. It's a feedback loop that can only end in one way, with the planet being completely consumed by its star. The discovery of WASP-18b's death spiral was made possible by precise measurements of the planet's orbital period over several years. Scientists found that the planet's orbit is decaying at exactly the rate predicted by tidal theory, confirming that the planet is indeed spiraling toward its doom. It's one of the few cases in astronomy where we can make precise predictions about the future of a celestial object. What makes this particularly haunting is the scale of the destruction that awaits. When WASP-18b finally spirals into its star, it won't simply disappear quietly. The planet's massive bulk will be torn apart by tidal forces as it approaches the star's surface, creating a spectacular display of destruction that will be visible across interstellar distances. The planet will be reduced to a stream of hot gas and debris that will be consumed by the star, briefly making it brighter as it digests the remains of its former companion. The planet's atmosphere is already being affected by its proximity to destruction. The intense heat and radiation from the nearby star are stripping away the planet's outer layers, creating a comet-like tail of gas that extends behind the planet as it orbits. This tail is made up of the planet's own atmosphere, being slowly torn away and fed into the star. The planet is being gradually consumed, even before its final destruction. The planet's magnetic field, if it has one, is probably being constantly disrupted by the extreme tidal forces. The planet is being stretched and compressed with each orbit, generating internal heat that adds to the already extreme temperatures. This tidal heating is literally cooking the planet from the inside, adding to the external heating from the star's radiation. The atmospheric composition of WASP-18b is probably changing as the planet approaches its death. The extreme heat and tidal forces are likely altering the chemical composition of the planet's atmosphere, creating exotic molecules and compounds that exist nowhere else in the universe. The planet has become a laboratory for extreme chemistry, where the normal rules of atmospheric science are being rewritten by the approach of destruction. The star itself is also being affected by this cosmic dance of destruction. The planet's gravitational influence is forcing the star to rotate faster than it would naturally, creating instabilities in the star's magnetic field and potentially triggering more violent stellar flares. The star is being slowly spun up by its doomed companion, creating a kind of stellar death spiral that parallels the planet's own destruction. What's particularly unsettling about WASP-18b is how it represents the ultimate futility of planetary existence. This world may have had billions of years to develop, to evolve, to potentially harbor life, but all of that time was merely a prelude to destruction, a brief moment of existence before the inevitable spiral into stellar annihilation. The planet is a cosmic reminder that even the most massive worlds are temporary, that all planetary systems are ultimately unstable. The planet's rapid orbital decay also affects its day-night cycle in unique ways. As the planet spirals inward, its orbital period is gradually decreasing, making its days shorter and shorter. An observer on the planet would literally watch the days getting shorter as the world approaches its doom, a countdown measured in the gradual acceleration of time itself. Scientists believe that WASP-18b's fate might be shared by many other hot Jupiters. The process of orbital decay might be common among planets that orbit too close to their stars. making these worlds temporary features of their stellar systems. The universe might be filled with planets in various stages of death spirals, racing toward destruction at different rates. 190 light-years from Earth, in the constellation Ursa Major, there exists a world caught in the most extreme orbital dance ever discovered. HD 80606b follows such an eccentric path around its star that it experiences temperature swings of over 1000 degrees Fahrenheit in just 6 hours, transforming from a frozen world to a blazing inferno and back again with each passage around its star. This is a planet that behaves more like a comet than a world, swooping through space in an elliptical orbit so extreme that it challenges our understanding of how planets can survive such gravitational violence. As we drift away from this world of inevitable destruction, we carry with us the knowledge that some cosmic endings are not sudden but gradual, measurable, and absolutely certain. WASP 18b reminds us that the universe operates on timescales that make even the most catastrophic events seem slow and predictable. The silence around WASP 18b
is the silence of a countdown that has been running for millions of years
and will continue for hundreds of thousands more until the final moment of stellar consumption. The planet's journey from the outer reaches of its orbit to its closest approach takes about 111 days, but the most dramatic changes happen in just a few hours. As HD 80606b swings around its star at closest approach, it experiences what astronomers call a thermal bomb, a sudden catastrophic heating that raises the planet's temperature by over 1000 degrees in just 6 hours. The planet goes from being cold enough to freeze carbon dioxide to being hot enough to melt lead, all in the span of time it takes to watch a few movies. Imagine being on the surface of this world during one of these thermal events. However, the temperature would rise so rapidly that any solid surface would begin to glow with heat, turning from black to red to white hot in a matter of hours. The atmosphere would be thrown into chaos as massive temperature gradients create winds that race around the planet at thousands of miles per hour. It would be like experiencing the most extreme weather event imaginable, but scaled up to planetary proportions. The planet's orbit is unlike anything in our solar system. While Earth maintains a nearly circular orbit around the Sun, HD 80606b follows a path so elliptical that it looks more like the orbit of a comet. At its closest approach, the planet skims just 3 million miles from its star, closer than Mercury is to our Sun. At its farthest point, it swings out to a distance of 90 million miles, roughly the same distance as Earth is from the Sun. This enormous variation in distance creates temperature swings that would make the planet uninhabitable for any life we can imagine. The atmospheric dynamics of HD 80606b are unlike anything we see elsewhere in the universe. The rapid temperature changes create massive atmospheric storms that dwarf anything we experience on Earth. As the planet heats up during its close approach, the atmosphere expands and becomes turbulent. Gases that were frozen at the planet's farthest point suddenly vaporize, creating enormous pressure waves that ripple around the planet. This planet calls een neef afar kan die verduwe February sove. This planet calls een neef afar kan die verduwe February sove. This planet calls een neef afar kan die verduwe February sove. This planet calls een neef afar kan die verduwe February sove. This planet calls een neef afar kan die verduwe fove. This planet calls een neef afar kan die verduwe fove. This planet calls een neef afar kan die verduwe fove. This planet calls een neef afar kan die verduwe fove. The planet's magnetic field, if it has one, is probably being constantly disrupted by these extreme temperature swings. The rapid heating and cooling would create electrical currents in the planet's atmosphere and interior, generating magnetic fields that change dramatically with each orbit. The planet would be surrounded by a constantly shifting electromagnetic environment that would make any kind of stable atmospheric structure impossible. Scientists believe that HD 80606b's extreme orbit is the result of a violent past. The planet probably started in a more circular orbit but was disturbed by a gravitational encounter with another object, perhaps another planet, a passing star, or even a stellar companion. This encounter scattered the planet into its current eccentric orbit, condemning it to an eternity of temperature extremes. The discovery of HD 80606b's extreme orbit was made possible by precise measurements of the planet's brightness as it orbits its star. Scientists found that the planet's temperature varies dramatically with its distance from the star, confirming the extreme nature of its orbital path. It's one of the most dramatic examples of how orbital mechanics can create uninhabitable conditions, even in systems that might otherwise be suitable for life. The planet's composition is probably unlike any other world we've discovered. The extreme temperature swings would create unique geological processes, with materials repeatedly melting and freezing with each orbit. The planet's surface, if it has one, would be constantly reshaped by these thermal cycles, creating a landscape that's perpetually in flux. The planet's atmosphere probably contains materials that exist in multiple phases, depending on where the planet is in its orbit. At the farthest point, these materials might be solid or liquid. At the closest approach, they would be vaporized, creating an atmosphere that's constantly changing composition. The planet has a kind of atmospheric memory, where the effects of previous close approaches influence the current atmospheric conditions. What makes HD 80606b particularly unsettling is how it represents the fragility of planetary orbits. This world shows us that planets can be scattered into orbits so extreme that they become uninhabitable, transformed from potentially life-bearing worlds into cosmic roller coasters of temperature and pressure. The planet is a reminder that gravitational encounters can completely reshape planetary systems, turning orderly arrangements into chaotic configurations. The planet's orbital characteristics also affect its day-night cycle in unique ways. The planet's rotational period is not synchronized with its orbital period, so different parts of the planet experience the extreme heating at different times. This creates a complex pattern of temperature variations that would make the planet's weather systems incredibly chaotic and unpredictable. The tidal forces experienced by HD 80606b during its close approaches are probably intense enough to deform the planet's shape. If the planet has a solid surface, it would be stretched and compressed with each orbit, generating internal heat that adds to the already extreme temperatures. The planet might be literally flexing with each passage around its star, creating geological activity that would make Earth's most violent earthquakes seem gentle. As we drift away from this world of extreme orbital mechanics, we carry with us the knowledge that planets can exist in states of perpetual instability, worlds that experience the most extreme environmental conditions imaginable. HD 80606b reminds us that the universe can take stable, potentially habitable worlds and transform them into cosmic nightmares through the simple mechanics of gravitational dynamics. The silence around HD 80606b is broken only by the imagined roar of atmospheric storms, driven by temperature swings that would destroy any world we can imagine calling home. The planet's future is probably as dramatic as its present. The extreme orbit will likely continue for millions of years, but gravitational perturbations from other objects in the system might eventually change the orbit again. The planet might spiral inward toward its star, or it might be ejected from the system entirely, sent wandering through interstellar space as a rogue planet. The planet orbits this pulsating star once every 1.2 days, which means it experiences multiple stellar pulsations during each orbit. As the star expands and contracts, the gravitational field around the planet changes strength and direction, creating tidal forces that would tear apart any solid object. The planet is essentially being gravitationally massaged by its star, stretched and compressed with each pulse in a process that generates enormous amounts of internal heat. The star that WASP-33b orbits is what astronomers call a delta scuti variable, a type of star that pulsates with mathematical precision. Every 2.5 hours, the star expands and contracts, changing its size, brightness, and gravitational field in a rhythm that has been maintained for millions of years. This pulsation creates a gravitational environment that's constantly changing, subjecting the planet to forces that no world in our solar system has ever experienced. 378 light-years from Earth, in the constellation Andromeda, there exists a world trapped in perhaps the most chaotic gravitational environment ever discovered. WASP-33b orbits a star that pulsates like a cosmic heartbeat, expanding and contracting in a regular rhythm that creates gravitational chaos throughout the entire system. This is a planet caught in a prison of perpetual motion, where the very space around it is constantly warping and flexing with each stellar pulse. The discovery of WASP-33b's pulsating environment was made possible by studying the planet's light curve as it transits in front of its star. Scientists found that the planet's atmospheric properties change in sync with the star's pulsations, confirming that the stellar variability is directly affecting the planet's environment. It's one of the most dramatic examples of how stellar activity can influence planetary conditions. The atmospheric effects of this stellar pulsation are beyond anything we can imagine. Each time the star expands, it becomes brighter and hotter, flooding the planet with increased radiation. Each time it contracts, the radiation decreases, creating a rapid cycle of heating and cooling that would drive the planet's atmosphere into perpetual chaos. The planet's weather systems would be in constant turmoil, with atmospheric pressures and temperatures changing dramatically with each stellar pulse. The planet's magnetic field, if it has one, is probably being constantly disrupted by the changing gravitational environment. The stellar pulsations create electromagnetic effects that would generate powerful magnetic field variations around the planet. These magnetic storms would be far more intense than anything we experience on Earth, creating aurora-like phenomena that would illuminate the entire planet's sky with each stellar pulse. The atmospheric composition of WASP-33b is probably unlike anything we see elsewhere in the universe. The constant temperature variations would create unique chemical reactions, with molecules being formed and destroyed with each stellar pulse. The planet's atmosphere would be a kind of chemical laboratory, where the normal rules of atmospheric chemistry are being rewritten by the extreme variability of the stellar environment. The planet's surface temperature varies dramatically with the star's pulsation cycle. When the star expands and brightens, the planet's day side can heat up by hundreds of degrees in just hours. When the star contracts and dims, the temperature drops accordingly. This creates a thermal environment that's constantly fluctuating, making any kind of stable surface conditions impossible. The planet's orbit is probably not stable over long timescales. The constant gravitational perturbations from the pulsating star would gradually change the planet's orbital parameters, potentially causing it to spiral inward or outward over millions of years. The planet is caught in a dynamic system where even its basic orbital characteristics are subject to change. The tidal forces experienced by WASP-33b are probably intense enough to affect the planet's internal structure. The constant flexing caused by the stellar pulsations would generate heat through tidal friction, potentially keeping the planet's interior molten, even if it started as a solid world. The planet might be literally being cooked from the inside by the gravitational forces of its pulsating star. The stellar pulsations also affect the planet's atmospheric escape. When the star expands and brightens, the increased radiation pressure would accelerate the loss of atmospheric material to space. When the star contracts, the atmospheric escape would slow down. This creates a kind of atmospheric breathing, where the planet's atmosphere is constantly being pushed and pulled by the stellar variations. The planet's day-night cycle is complicated by the stellar pulsations. Not only does the planet experience the normal variation between day and night sides, but it also experiences the additional variation caused by the star's changing brightness. This creates a complex pattern of illumination that would make the planet's energy balance incredibly dynamic and unpredictable. The planet's future is probably as chaotic as its present. The stellar pulsations will likely continue for millions of years, subjecting the planet to constant gravitational chaos. Scariest. The planet might eventually be torn apart by tidal forces, or it might be ejected from the system entirely by the cumulative effects of the gravitational perturbations. The atmospheric dynamics of WASP-33b probably create unique phenomena that exist nowhere else in the universe. The planet might experience atmospheric tides that rise and fall with each stellar pulse, creating pressure waves that ripple around the planet. The planet's weather systems would be driven not just by temperature differences, but by the constantly changing gravitational environment. What makes WASP-33b particularly unsettling is how it represents the ultimate lack of stability in planetary environments. This world shows us that planets can exist in gravitational environments so chaotic that they challenge the very concept of stable planetary conditions. The planet is a reminder that some stellar systems are so dynamic that they make long-term planetary habitability impossible. Scientists believe that WASP-33b might be representative of a class of planets that orbit variable stars. These worlds would all experience similar gravitational chaos, making them uninhabitable despite potentially being in the right orbital distance for liquid water. Also, the universe might be filled with planets trapped in similar pulsating prisons, worlds that can never achieve the stability necessary for life. The silence around WASP-33b is broken only by the imagined rhythm of stellar pulsations, a cosmic heartbeat that has been driving this world toward chaos for millions of years. As we drift away from this world of gravitational chaos, we carry with us the knowledge that planets can exist in environments so dynamically unstable that they challenge our understanding of what constitutes a planetary system. WASP-33b reminds us that the universe can create gravitational environments so extreme that they make stable planetary conditions impossible. The planet orbits its star at a distance of only 900,000 miles, roughly twice the distance between Earth and the Moon. At this proximity, the planet receives 3,000 times more energy from its star than Earth receives from the Sun. The day side of the planet reaches temperatures of over 4,000 degrees Fahrenheit, hot enough to vaporize rock and create an atmosphere of stone vapor. Yet somehow, this world maintains its structural integrity in an environment that should have destroyed it billions of years ago. 700 light-years from Earth, in the constellation Cygnus, there exists a world that simply should not exist according to everything we thought we knew about planetary formation. Kepler-78b is a planet that orbits so close to its star that it completes one full orbit in just 8.5 hours, faster than most people's workday. This proximity places it in a region where no planet should be able to form or survive. Yet here it is, defying our models of planetary physics and challenging our understanding of how worlds come to be. What makes Kepler-78b truly impossible is not just its current location, but the fact that it could never have formed where it is now. According to our understanding of planetary formation, rocky planets form from the gradual accumulation of dust and debris in the cooler regions of a protoplanetary disk. But the region where Kepler-78b orbits would have been occupied by the star itself when the planet was forming. The planet is literally orbiting within what would have been the star's original photosphere, the glowing outer layer of the young star. The planet's surface composition is probably unlike anything we see elsewhere in the universe. The extreme heat would have vaporized any volatile materials, leaving behind only the most refractory elements, materials that can withstand the highest temperatures. The planet's surface might be made of exotic high-temperature compounds that don't exist naturally anywhere else, created by the extreme conditions of its stellar environment. The discovery of Kepler-78b forced astronomers to reconsider their models of planetary formation and migration. The planet must have formed much further from its star and then migrated inward, but the migration process that could move a rocky planet to such an extreme orbit is not well understood. The planet represents a kind of cosmic mystery, a world that exists in defiance of our theoretical framework for how planetary systems develop. The atmospheric dynamics of Kepler-78b are equally challenging to understand. The planet is so close to its star that it's probably tidally locked, with one side permanently facing the star, while the other remains in darkness. The temperature difference between these sides would create atmospheric circulation patterns, unlike anything we see on other worlds. The day side would be covered in clouds of vaporized rock, while the night side might experience rain made of condensed stone vapor. The tidal forces experienced by Kepler-78b are probably intense enough to keep the planet's interior molten. The star's gravity would create tidal bulges in the planet's crust, generating heat through tidal friction. This internal heating would add to the already extreme surface temperatures, creating a world that's being cooked from both outside and inside. The planet might be in a state of perpetual geological activity, with volcanic processes that never cease. The planet's magnetic field, if it has one, is probably being constantly disrupted by the intense stellar radiation and the planet's proximity to the star. The magnetic field lines would be compressed and twisted by the stellar wind, creating a complex electromagnetic environment that would make any kind of stable atmospheric structure impossible. The planet might be surrounded by a kind of permanent aurora as charged particles from the star interact with whatever magnetic field the planet can maintain. The planet's orbit is probably not stable over long timescales. The tidal forces that keep the planet's interior molten are also gradually removing energy from the planet's orbital motion, causing it to spiral slowly inward toward its star. The planet is probably destined to eventually be consumed by its star, making it a temporary feature of its stellar system. The atmospheric composition of Kepler-78b probably includes elements that should never exist as gases. Silicon, magnesium, iron, and other rock-forming elements are likely floating as vapor in the planet's atmosphere, creating a chemical environment that exists nowhere else in the known universe. The planet has become a laboratory for extreme chemistry, where the normal rules of atmospheric science are being rewritten by impossible conditions. The discovery of Kepler-78b also raised questions about how common such impossible worlds might be. If one planet can exist in such extreme conditions, there might be others waiting to be discovered. The universe might be filled with worlds that challenge our understanding of planetary physics, planets that exist in conditions we thought were impossible for world formation or survival. The planet's size and mass are remarkably similar to Earth's, making it one of the most Earth-like planets ever discovered in terms of basic physical properties. But this similarity only makes the planet's impossible environment more striking. Here is a world that could have been Earth's twin, but instead exists in conditions that would vaporize our planet in seconds. Scientists believe that Kepler-78b might be the stripped core of a former gas giant, a world that lost its atmosphere and outer layers to stellar radiation over billions of years. What we see today might be the naked heart of a former giant planet, compressed and heated until it became the impossible world we observe today. The planet's future is probably as dramatic as its present. The gradual orbital decay will eventually bring the planet close enough to its star to be torn apart by tidal forces. When this happens, the planet will be reduced to a stream of vaporized rock that will be absorbed by the star, briefly making it brighter as it digests the remains of its impossible companion. The planet's rapid orbital period means that it experiences time differently than we do. A year on Kepler-78b is shorter than a human workday, making the planet's existence feel frantic and desperate. The world is racing around its star as if trying to outrun the forces that should have destroyed it long ago. As we drift away from this world that defies explanation, we carry with us the knowledge that the universe is far stranger and more complex than our models suggest. Kepler-78b reminds us that planets can exist in conditions we thought were impossible, challenging our understanding of what's possible in the realm of planetary science. The silence around Kepler-78b is the silence of a cosmic mystery, a world that exists in defiance of everything we thought we knew about how planets form and survive. 1,200 light-years from Earth, in the constellation Hercules, there exists a world that has been literally stretched into an egg shape by the gravitational forces of its star. WASP 103b is a planet so close to its stellar parent that it's being pulled and distorted, like cosmic taffy, deformed into an elongated shape that makes it look more like a giant egg than a spherical world. This is a planet that's being slowly torn apart by tidal forces, stretched to the breaking point in a gravitational tug-of-war that it cannot win. The tidal forces that create this distortion are the same forces that create ocean tides on Earth, but magnified to an unimaginable degree. On Earth, the moon's gravity creates tidal bulges in our oceans that rise and fall by a few feet. But on WASP 103b, the star's gravity creates tidal bulges that distort the entire planet, stretching it by hundreds of miles along its longest axis. The planet is being constantly pulled and squeezed by forces that would tear apart any solid object. The discovery of WASP 103b's egg shape was made possible by precise measurements of the planet's light curve as it transits in front of its star. Scientists found that the planet's silhouette
is not circular but elliptical.
confirming that the world has been deformed by tidal forces. It's one of the most dramatic examples of how gravitational forces can physically reshape entire worlds. The planet orbits its star once every 22 hours, so close that it's nearly touching the star's outer atmosphere. At this proximity, the gravitational forces are so intense that they overcome the planet's own gravity, pulling it into a teardrop shape with the pointed end facing the star. The planet has been transformed from a sphere into an ellipsoid, stretched along the axis that points toward its stellar parent, like a cosmic egg about to hatch into destruction. The planet's atmosphere is probably being constantly stripped away by the intense tidal forces. The stretching and compression of the planet would create atmospheric turbulence that would make any kind of stable weather patterns impossible. The atmosphere would be in constant motion, with gases being pulled toward the star and then swept around the planet by the complex gravitational environment. The planet's magnetic field, if it has one, is probably being constantly disrupted by the tidal distortion. The stretching and compression of the planet would affect the movement of any electrically conductive materials in the planet's interior, creating complex magnetic field patterns that change with the planet's orbital motion. The planet would be surrounded by a chaotic electromagnetic environment that would make any kind of stable magnetic structure impossible. The internal structure of WASP 103b is probably unlike anything we see in our solar system. The constant tidal flexing would generate enormous amounts of heat through friction, keeping the planet's interior molten, even if it started as a solid world. The planet might be literally being cooked from the inside by the gravitational forces that are shaping its exterior. The planet's rotational characteristics are probably affected by the tidal forces as well. The gravitational interaction with the star would tend to synchronize the planet's rotation with its orbital period, creating a tidally locked world where one side always faces the star. But the extreme tidal distortion might create more complex rotational behavior, with the planet's rotation being affected by the changing gravitational forces. The surface of WASP 103b, if it has one, would be a landscape of impossible geology. The constant tidal forces would create mountain ranges that rise and fall with the planet's orbital motion, valleys that stretch and compress, and geological features that exist nowhere else in the universe. The planet's surface would be in constant flux, reshaped by gravitational forces that never cease. The atmospheric composition of WASP 103b is probably dominated by the effects of atmospheric escape. The tidal forces would accelerate the loss of atmospheric material to space, stripping away the lighter elements and leaving behind only the heaviest compounds. The planet's atmosphere would be constantly changing composition as it's gradually eroded by the stellar environment. The discovery of WASP 103b's distorted shape has important implications for our understanding of planetary structure and evolution. The planet shows us that worlds can be physically deformed by gravitational forces, transformed from spheres into more complex shapes by the extreme environments they inhabit. It's a reminder that planets are not rigid objects, but dynamic systems that can be reshaped by the forces acting upon them. The planet's future is probably as dramatic as its present. The tidal forces that are currently stretching the planet into an egg shape will eventually overcome the planet's structural integrity entirely. The planet will be torn apart, reduced to a stream of debris that will be absorbed by the star. This process might take millions of years, but it's inevitable given the extreme gravitational environment. The planet's egg shape also affects its thermal properties in unique ways. The elongated shape would create complex heat distribution patterns, with different parts of the planet receiving different amounts of stellar radiation. This would create temperature gradients that don't exist on spherical worlds, driving atmospheric circulation patterns that are unlike anything we see elsewhere in the universe. Scientists believe that WASP 103b might be representative of a class of planets that are being tidally distorted by their stars. These worlds would all experience similar shape changes, making them cosmic laboratories for studying the effects of extreme gravitational environments on planetary structure. The universe might be filled with egg-shaped worlds, all being slowly torn apart by the stars they orbit. The planet's distorted shape also affects its orbital dynamics. The elongated shape would create additional gravitational interactions with the star, potentially causing the planet's orbit to decay more rapidly than it would if the planet was spherical. The planet is being destroyed, not just by tidal forces, but by the orbital instability that results from its own distortion. As we drift away from this world of impossible shape, we carry with us the knowledge that planets can be physically transformed by the gravitational environments they inhabit. WASP 103b reminds us that the universe can take spherical worlds and stretch them into cosmic eggs, demonstrating the power of gravitational forces to reshape entire planets. 2,300 light-years from Earth, in the constellation Virgo, there exists a world that orbits not a star, but the corpse of a star, a neutron star, that spins 30 times per second and emits beams of deadly radiation across the galaxy. PSRB 1257 plus 12b is a planet that exists in perhaps the most hostile environment possible, bathed in constant radiation from a stellar remnant so dense that a teaspoon of its material would weigh as much as a mountain on Earth. This is a world that has somehow survived the death of its star, only to find itself trapped in a lighthouse of cosmic destruction. The silence around WASP 103b is the silence of a world being slowly pulled apart, stretched into an impossible shape by forces that will eventually destroy it completely. The pulsar at the center of this system is what remains after a massive star exploded in a supernova billions of years ago. The explosion should have destroyed any planets in the system, vaporizing them instantly and scattering their remains across interstellar space. Yet somehow, PSRB 1257 plus 12b survived this cosmic catastrophe, or perhaps formed from the debris afterward. The planet now orbits this stellar corpse every 25 days, locked in a gravitational dance with one of the most extreme objects in the universe. The pulsar emits beams of radiation that sweep across the planet's surface like a cosmic lighthouse. These beams are made up of high-energy particles and electromagnetic radiation that would be instantly lethal to any form of life. The planet is constantly bombarded by radiation levels that are billions of times higher than anything we experience on Earth, creating a surface environment that's been sterilized and re-sterilized countless times over the billions of years since the pulsar formed. The magnetic field around PSRB 1257 plus 12b is probably one of the most complex and powerful in the known universe. The pulsar's magnetic field is trillions of times stronger than Earth's, and it extends throughout the entire system. The planet exists within this magnetic field, subjected to electromagnetic forces that would tear apart any normal matter. The planet's own magnetic field, if it has one, would be completely dominated by the pulsar's magnetic environment. The planet's surface is probably unlike anything we can imagine. The constant radiation bombardment would have altered the very atomic structure of the planet's crust, creating materials that don't exist anywhere else in the universe. The surface might be covered in exotic compounds formed by the interaction of matter and intense radiation, substances that could only exist in the extreme environment of a pulsar system. The discovery of PSRB 1257 plus 12b was one of the most significant moments in astronomy. It was the first confirmed exoplanet ever discovered, found by detecting tiny variations in the pulsar's timing as the planet's gravity tugged on the neutron star. The planet's existence proved that worlds could survive in the most extreme environments, challenging our understanding of planetary formation and survival. The planet's internal structure is probably affected by the intense radiation as well. The high-energy particles from the pulsar would penetrate deep into the planet's interior, heating the core and potentially keeping it molten through radiation heating. The planet might be glowing with its own internal heat, warmed not by radioactive decay, but by the constant bombardment of pulsar radiation. The planet's atmospheric composition, if it has an atmosphere at all, would be dominated by the effects of radiation processing. The intense radiation would break apart any molecules in the atmosphere, creating a thin envelope of atomic particles around the planet. Any atmosphere would be constantly stripped away by the radiation pressure, making the planet essentially airless. The planet's rotation is probably synchronized with its orbit around the pulsar, creating a tidally locked world where one side always faces the neutron star. The side facing the pulsar would receive the full force of the radiation beams, while the far side would be relatively protected. This would create extreme temperature differences between the two sides, driving atmospheric circulation patterns, unlike anything we see elsewhere. The planet's orbit is probably extraordinarily stable, despite the extreme environment. Pulsars are among the most precise timekeepers in the universe, and the planet's orbital period can be measured with incredible accuracy. The gravitational environment around a pulsar is so predictable that the planet's orbit remains constant to within fractions of a second over years of observation. The surface temperature of PSR B 1257 plus 12b is probably determined largely by the radiation heating from the pulsar. The planet might be warm despite its distance from the neutron star, heated by the constant bombardment of high-energy particles. The surface might glow with a faint light, illuminated by the interaction of radiation with the planet's crust. The planet's future is probably as stable as its present. Pulsars are incredibly long-lived objects, and the radiation environment around PSR B 1257 plus 12 will remain constant for billions of years. The planet will continue its orbital dance around the neutron star, bathed in radiation that would sterilize any world we can imagine, but somehow providing a stable environment for this impossible world. The discovery of PSR B 1257 plus 12b changed our understanding of where planets can exist. Before this world was discovered, we assumed that planets required normal stars to survive. But this planet showed us that worlds can exist around the most extreme objects in the universe, opening up new possibilities for planetary formation and survival in environments we never thought possible. The planet's existence also raises questions about the possibility of life in such extreme environments. While the radiation levels would be lethal to any Earth-like life, there might be forms of life that could exist in such conditions, perhaps using the radiation itself as an energy source. The planet represents a kind of cosmic laboratory where life might evolve in ways we can barely imagine. Scientists believe that PSR B 1257 plus 12b might be the remnant of a much larger planet that was partially destroyed by the supernova that created the pulsar. The world we see today might be the surviving core of a former gas giant, stripped of its atmosphere and outer layers by the stellar explosion, but somehow maintaining its structural integrity. The planet's surface is probably covered in craters from billions of years of bombardment, not by asteroids, but by the debris from the supernova that created the pulsar. The planet bears the scars of witnessing the most violent event in stellar evolution, a world that has survived the death of its star and found a new existence in the aftermath. As we drift away from this world of the dead star, we carry with us the knowledge that planets can exist in the most extreme environments imaginable. PSR B 1257 plus 12b reminds us that life and death in the universe are more complex than we imagine, and that worlds can find ways to survive even the most catastrophic events. The silence around PSR B 1257 plus 12b is broken only by the regular pulse of radiation from its neutron star companion, a cosmic heartbeat that has been marking time for billions of years. 815 light-years from Earth, in the constellation Vela, there exists a world that is literally evaporating into space, losing mass so rapidly that it leaves a comet-like trail of its own atmosphere behind it as it orbits its star. WASP-19b is a planet that's being slowly consumed by the intense radiation from its stellar parent, shrinking year by year as its atmosphere is stripped away and blown into the cosmic wind. This is a world that's dying before our eyes, dissolving into space like a cosmic ice cube melting in the heat of its star. The planet orbits its star once every 18.9 hours, so close that it's literally skimming through the star's outer atmosphere. At this proximity, the planet receives nearly 8,000 times more energy from its star than Earth receives from the Sun. The day side of the planet reaches temperatures of over 3,600 degrees Fahrenheit, hot enough to vaporize most materials and turn the planet's atmosphere into a superheated gas that's constantly trying to escape into space. Escape into space. Escape into space. The mass loss from WASP-19b is happening at a rate that's almost incomprehensible. The planet is losing approximately 300 billion tons of material every second, mass that's being blown away by the intense stellar radiation and never returning. To put this in perspective, that's equivalent to losing the mass of a small mountain every second, material that's being converted from solid planet into cosmic gas and scattered across the star system. The atmospheric escape from WASP-19b creates a spectacular display that's visible to our telescopes. The planet leaves behind a trail of hot gas that extends for millions of miles, making it look like a giant comet streaking through space. This trail is made up of the planet's own atmosphere, heated to such extreme temperatures that it glows with its own light and can be detected across hundreds of light-years of space. The planet's atmospheric composition is being constantly altered by the mass loss process. The lighter elements, hydrogen and helium, are being stripped away first, leaving behind the heavier elements that require more energy to escape. The planet's atmosphere is essentially being distilled by the stellar radiation, with the composition changing as the lighter materials are boiled away into space.